everyone. My name is Amrit Kumar, and I'm the Chief Operating Officer at Altlayer. We're building a Rollups-as-a-service platform. So, evidently, this part of the educational series is going to be on Rollups-as-a-service. So, try to understand what it is, what makes a Rollup-as-a-service, and what it actually offers to end users and end clients. So, before we do that, let me give you a little bit of background on why people are building Rollup-as-a-service and why we actually need them. So many of the people in the space, you must be familiar with chains, L1s like Ethereum, Solana, and others. Basically, they operate in a monolithic model where you have these nodes in the network that process your transactions. So they basically execute transactions. They reach consensus on the transactions. So basically, the set of the transactions and the state of the system. And they basically make sure that the data, the transaction data, is available for the people to check and verify the state. So this is how almost every single chain that's out there in the market today operates. There's the second paradigm, which is often called a modular blockchain stack, where the idea is to basically separate these components outside and not ensure that all of these components are running on a single platform or single L1. And so you take out execution, and that basically becomes rollups, right? So you see the likes of Optimism, Arbitrum, zkSync, they're all execution layers. So they execute transactions and they're attached to a base layer, which is Ethereum. The second part is the settlement layer. So we're basically, it is the network which basically decides on whether a certain state of the rollup is correct. So for example, if you are looking at a zk rollup, then the settlement layer basically verifies the proofs generated by the zk rollup. And the third part is the consensus NDA. Basically, it's the network that decides the ordering of the transactions and make sure that those transactions are available for someone, let's say, who wants to prove that the system is operating in the right way. So over the last year or so, it has been well established that modular design philosophy or modular design stack is the way to basically scale blockchains. And so almost every single, my belief is that almost every single monolithic chain will end up becoming a settlement layer or a consistent DA layer. And execution is the one component that will obviously move out of the base chain. And the good thing is that once you move out the execution component, you can actually build interesting things. So for example, imagine you are building today on Ethereum. You're bound by the runtime that Ethereum offers you. So for example, Ethereum currently offers EVM, so you can only run contracts that compiles down to EVM. But what if you wanted to run WASM? What if you wanted to run a Solana VM or something of that kind? You can only do that on an execution layer if it's outside of Ethereum. So rollups basically enable that possibility, make it possible for you to basically run an arbitrary runtime, but still stay attached to a certain settlement layer like Ethereum. And because of this, popularity of modular, chain stack, my personal belief is that execution is the stack that will see the most number of, or so far even by the way, has actually seen the most activity in let's say, in terms of developer activities. It has seen the most amount of work being done. And because of that execution, because execution has moved out of the base chain, we started to see different kinds of execution layer being built. So for example, imagine, the simplest case would be considering, let's say, optimistic rollups versus zk rollups, right? So your rollup basically execution layer has a certain type of security guarantees. A security guarantee could come from a fraud-proof based mechanism, or it could come from a cryptographic proof, which is like your zk rollups. A rollup or execution layer could have different runtimes, as I mentioned earlier. So it could be runtime, it could be running EVM, it could be running WASM, it could be running Solana VM, or more recently, you could even imagine running something like a Move VM. An execution layer may also have a certain purpose. So you could imagine an execution layer like Arbitrum Optimism that serves a general purpose, right? So imagine deploying all sorts of contracts on that rollup. So similar to what you can do on Ethereum today. But you could also imagine building execution layers that are sector specific. So imagine building something like a DeFi rollup on which you can put applications like Aave, MakerDAO, and Uniswap and the likes. Or you could go even more sort of fine grained, and you could say, hey, let's go and build an app specific rollup. So you could say, hey, I'm building a fully on-chain game, and I want to make sure that this game runs with a certain setting. For example, let's say I don't want to have gas mechanics on my network. Can you do that? You can do that only if you build an app specific execution layer. And there's this last category which I call ephemeral rollups. So these are rollups that you can spin up and you can use them for as long as you want. And when you feel like you're done with it, you don't need them anymore, you can take them down. So these are basically temporary rollups. These are rollups that you spin up only if you need them, and when you don't need them, you can take them down. And then the last, trait of these rollups could be, or execution layers could be, on which chain do they settle. So they could be settling on a layer 1, like Ethereum, or they could be settling on a layer 2, like, let's say, Arbitrum, Optimism, and others. And so basically, by the way, these are not an exhaustive, I would say, traits that you could imagine for execution layers. You could imagine other things, for them as well. But basically, the idea is that once you have pushed out execution out of a base chain, out of a monolithic chain, you get all the flexibility. And that flexibility basically creates opportunity to build different kinds of execution depending on what you actually want them to achieve. So a good example would be, you could imagine building an application-specific execution layer that uses fraud proofs, but relies on, let's say, runs EVM, but is actually settling on a base chain which runs WASM, for example, near protocol. And you could do that only if you move execution out of that. So it's all good. However, when you launch all these when the execution moves out and when you start to launch different kinds of execution layer, you actually do see a problem. And the problem is around fragmentation of the execution space. So you can imagine if you're a builder, now you have the problem to decide, okay, which kind of rollup, which kind of execution layer do I choose and pick, and how do I customize them to suit my needs, right? And there are n number of execution layers out there in the market today. Of course, from the more popular ones, like, let's say, zkSync, Polygon, Arbitrum, Optimism, which are much more general purpose in nature, to much more sector specific as well. So you could imagine Arbitrum Nova, which is designed for game specific, or those kind of applications which require low gas fees, and they basically rely on a certain type of D layer and do not necessarily settle on Ethereum. You could imagine different kinds of, and there's different kinds of rollups that use certain runtimes. So not necessarily EVM, but maybe WASM. You have rollups that do not actually have any settlement layer, like sovereign rollups, right? So basically, now you have this wide variety of execution layers that are out in the market. From a developer perspective, at some point you have to decide and choose which one is the right choice for you. And this is where there are some pain points. So one is developers. If you're building a dApp, you have to deal with all the heterogeneity that comes from the execution layers that are out in the market today. And there's no, I would say, unified framework that could use to decide and spin up these instances of execution layers. And even worse, imagine if you do not have a, let's say, dedicated technical team. And let's say if you're building an NFT project, if you're building a gaming project where you do not understand the technicalities of how rollups work, some of these rollup SDKs that are being offered today, they can be a little bit intimidating. So it could be too low level for you to understand and use. And so there are benefits of moving execution out of the base chain and have this modular approach. But then there are demerits and disadvantages as well. And this is what I'm trying to mention here, which is it becomes a little bit complicated for people to pick and choose. To give an example why it's important, how challenging this problem is. DeFi is not a great example, but you could pick any instance of any, let's say, app chain today. Generally speaking, it takes quite a bit of time today to go and spin up an L1, go and spin up an app chain or app rollup. To be honest with you, it looks like, if DeFi is an example, the reason why I'm putting this because it is one of the biggest applications in the Ethereum space that is building an app chain today. It's not necessarily rollup, but you can imagine why rollups become interesting and why it becomes easier why it's important to make sure that the mistakes or the issues that we see in the app chain space should not be repeated in the app rollup space. And so back in 2017, a lot of people were building different kinds of L1s. So for example, Tesos, Polygon, Solana, and Ethereum as well. Ethereum a little bit much earlier, but basically at that time, it took about 1.5 years, sometimes 2 years, 3 years to actually build a fully, performing blockchain like an L1. And if you look at DYDX, which decided to launch their own app chain recently, I think it was yesterday or today when the DYDX mainnet went live. It took them at least a year and a half, if not more, by the way. So what I'm trying to argue here is that the time to launch an app chain is kind of the same or roughly the same as the time to launch an L1, which is not ideal because the whole point of some of the SDKs that are out there was to basically make sure that the time to launch these app-specific chains would be much shorter, and that's not really the case. Of course, in some cases, of course, if you're not customizing too much, it should be straightforward. But there are certain challenges by if you're launching an app chain. And the underlying point is that blockchain infra is still in a stage where you still have to do a lot of hand holding. You still have to put a lot of manpower in building an app specific infrastructure. And this is what we should change. And this is what I think rollups have the ability to change. And so the question that I would like to raise here is, if you wanted to build and make it easier for people to deploy or launch an application-specific execution layer or application-specific rollups, we believe that there's something to learn from Amazon Web Services, even though many people in the crypto space may not like AWS. But the fact of the matter is, AWS is one of the backbones of almost every single company that's out there in the space today, right? From startups to pretty much well-established companies as well. So there's something to learn from Web 2, and I think this is what where Rollup-as-a-service comes into play. So basically, if you look at AWS, when you want to, let's say, launch an app and you want to host your app somewhere, in the prehistoric or the pre-AWS era, basically you had to go and buy hardware, you have to go and buy servers and then put all your application, host your application on those servers. And it was not very scalable because imagine, let's say your application drives a lot of transaction volume during, let's say, Christmas time. You had to go and buy hardware before Christmas, and post Christmas, when the sales have gone down, you basically had to figure out a way in which you could basically reduce your expenses by removing some of the hardware that you're operating. And so the goal was AWS was to basically make sure that your system runs much more efficiently and in an optimized way. So it basically helps you reduce the cost. And this is kind of what we want to achieve with our execution layers as well. Where basically you want to make sure that anyone who wants to spin up an execution layer of any type should not worry too much about burning millions of dollars of money to build that rollup. The second thing, it has to be fast, right? In the sense that when you want to spin up this rollup, it should be for today. Let's say, imagine you're building a startup. AWS helps you in many ways, right? One is basically you can go and spin up an instance quite quickly, and you can take them down if you don't like it, or if you feel like you want to use that anymore. And so you want to have an infrastructure that basically enables rapid innovation and basically scales with the application. And that's something that doesn't happen that well with the infra that exists today in the market, right? And the other thing that I like to highlight here is that unlike AWS, which offers a very centralized service, an ideal model to make it possible for people to deploy application-specific rollup should be a model that is somewhat decentralized, somewhat trustless, and somewhat permissionless. And this is what many of the Rollup-as-a-service builders are doing today, right? So basically, for those who are new to the space and for those who are not familiar with what Rollup-as-a-service is and does, basically they offer and help you run your rollups. So imagine you are a game builder and you are building a fully on-chain game, and you feel like it'd be best if you run this your game on an app-specific rollup because you do not want to worry about gas mechanics and things like that. And you want to, for example, offer a gasless experience, right? You can only do that if you could customize the underlying rollup. And so basically, you do not want to worry about, who is going to run my sequencer? How am I going to run my RPC endpoints, my explorers, my indexers, and so on? So you basically outsource all of that infrastructure support back to a provider that is basically the RaaS provider, the Rollup-as-a-service provider. They will basically run this service for you, where you do not have to worry about hosting any of the node infrastructure that comes with it. And so many of these Rollup-as-a-service operators that exist in the market today, they offer somewhat like a SaaS model where you as a developer, you basically pay them some sort of monthly fee, and they allow you to host their rollup on their infrastructure. Now, here's an example of somewhat, how this rollup-as-a-service service could look like, where basically you go to a dashboard similar to a SaaS-like dashboard, and where you can go and say, hey, I want to deploy a rollup. I don't want to write any line of code, and can I do that? So basically, this dashboard would allow you to basically click and pick and choose and customize different things. For example, you could say, hey, I want to have my own gas token. I want to have a certain block gas limit and things like that. You could basically do that with just clicks and buttons. You do not have to write any single line of code. So all the complexity of an underlying SDK, for example, let's say you're using OP Stack or Arbit from Orbit, those sort of things, they all kind of get taken away from you. So basically, it becomes much more simpler for you if you want to go and deploy a rollup. If you want to get a feel of it, you can go to dashboard.all-technology and you can get a sense of how easy it has become to deploy rollups through some of the RaaS services that are out there in the market. Now, let me highlight again what are the benefits of RaaS. So one, it's low cost. It should be low cost because you do not want to go and spend millions of dollars in hiring the right kind of people to go and deploy this. And two, it should be low cost in the sense that it should be fast to spin up and fast to take them down if you don't need them anymore. Many of these RaaS providers actually should offer and actually do offer a no-code framework where you do not have to be an expert in rollups and blockchains. Even if you're a marketing person or a BD person or a project manager, you should be able to go and deploy a rollup through a no-code dashboard, no-code framework. And the other thing is, because it's a universal, most RaaS providers offer kind of universality. Basically, what I mean by this is you go to RaaS dashboard or RaaS platform, and you'd be able to pick and choose, let's say, your settlement layer, your DA layer, and different other services that you would like to use. And so it becomes like one single platform that allows you to pick and choose different bits and pieces that you would need for your rollup. And this way, you as a developer, you can focus on your core expertise. So, for example, if you're a game builder, you'd focus on building good and fun and engaging games rather than worrying about the backend infrastructure and how that runs. Now, as I mentioned, many of the RaaS providers or RaaS service kind of sounds like a SaaS model where basically you pay them, a RaaS provider, a certain amount of money per month, and they basically offer you this nodes infrastructure services. Now, there's one thing that you have to, both as a user and both in this space as well, you have to understand how they operate. So typically, if you look at the SaaS business model in particular, there are different ways in which SaaS products actually make money. So you could imagine a flat pricing model where anyone has to pay, I don't know, $10 a month for using that SaaS service. There could be models where you pay them, in based on some usage or some tiers. So you could say, if you're using it for, let's say, I don't know, this many transactions or this much of data, then you're allowed. You would have to pay, let's say, $100 a month. If you're using in a certain different tier, you would have to pay slightly higher. There are different hybrid pricing models as well. And on the other hand side, there are models which are much more metric based, where you'd say, depending on how many users are coming in, depending on how much traffic you're driving to the SaaS platform, they will charge you based on those metrics. As you can imagine, not all of these models are ideal for RaaS products. So if you're a RaaS builder or if you want to use a RaaS service, you could imagine not many of them are actually going to be a good fit. And this is where things become interesting, because a RaaS provider has to consider a certain cost, and that cost basically goes back to the end clients, right? The first cost is the cost of, let's say, if you're building, let's say, optimistic rollup or a zk rollup, you have to consider the execution cost. So basically the cost of running and processing your transactions. And because that's basically run and managed by the RaaS provider, RaaS provider has to basically take that cost into account. The second thing is the proof cost. So basically the cost of, if let's say the RaaS provider is provisioning a zk rollup for you, in that case, the RaaS provider might actually be running a prover. And so there's a certain cost that is associated with running the prover itself, because provers at the moment are quite expensive. And it takes quite a bit of time to generate proofs. And so proofs are quite beefy. And so the RaaS provider has to take in account the proof generation cost as well. The second cost is the DA cost, because eventually you might be actually posting data back on certain DA layer, right? So it could be Ethereum, it could be Celestia, it could be some other networks. So there's a cost that these RaaS providers have to pay for the DA cost. In some cases, and depending on which rollup stack you choose, in some cases you do not have to pay for DA itself, because DA in the sense that you don't have to pay for the transaction publishing itself, but you have to pay for the state delta. For example, there's a rollup that does not put the full raw transaction data on Ethereum, but only puts the difference between the previous state and the current state. The RaaS provider also has to, in some cases, has to post these validity proofs, and these validity proofs basically gets verified on chain, and so there's a cost associated with that as well. And so in this course, I'm removing and not taking into account any cost that comes from, let's say, manpower. So because a RaaS provider has to go and build a team to be able to help you establish and help you run these rollups, I'm not taking any of that into account. I'm mostly looking at the cost that's, let's say, the bare minimum that the RaaS provider has to pay, because RaaS provider cannot escape the proof generation cost in case of zk. It cannot escape the DA cost. It cannot escape the cost of proof verification on chain. So that's the bare minimum cost that the RaaS provider obviously has to pay. And then, of course, there's additional cost of, let's say, non-infra cost, which is the manpower cost, for example. Let's take a look at the cost depending on which rollup RaaS provider provisions for you. So imagine if you're using a zk rollup. zk rollups today are actually quite more expensive than optimistic rollups, simply because they require proof generation, and proof generation requires very beefy infrastructure, and so it is quite expensive. And I'm not talking about the gas fee cost. I'm talking about the gas fees can be much cheaper. So if you are, let's say, using a zk rollup from an end user perspective, the cost of running the cost of sending a transaction is actually could be much cheaper compared to an optimistic rollup. But from infra providers, someone has to go and run that proof, and that prover is actually expensive. The second part is the DA cost, basically the cost of putting the data. So imagine if you're running zk rollup, there are certain zk rollups, as I said earlier, they do not put the raw transaction data on the Ethereum, so the cost is actually quite cheaper compared to if you had put all the raw transaction data on Ethereum. And so if you're putting just the state delta on Ethereum, then your zk rollup can actually have a lower DA footprint compared to an optimistic rollup, because an optimistic rollup, in general, they actually put the whole transaction data. There's a cost of, as I said, of verifying the proofs that you put on Ethereum. That obviously doesn't exist in optimistic rollups, but so it only applies to zk rollups, and so there's a cost for that as well. And similarly, the cost of proof verification that does not exist in optimistic rollup, but that does exist in zk rollups. There's one thing that I haven't mentioned on this slide, which is the fraud proof part. So fraud proofs at the moment do not get triggered simply because most of the rollups, or if not all of the optimistic rollups today in the market, they operate with centralized sequences, and so the chances that a centralized sequencer will make malicious, let's say, state commitments is actually quite low. So which means that fraud proofs actually never get triggered, practically speaking and realistically speaking, given the current settings of many optimistic rollups. And so now going back to the business model that I mentioned earlier, you could have everything that's on the right in the box. So freemium model, fiat pricing, tiered pricing, user pricing, hybrid pricing. These are not quite ideal for RaaS models, because they are very predictable, right? So you know how much. If you're looking at fiat pricing, a flat pricing model, you kind of know that, okay, my user will have to pay $10. That's not really the case with blockchain systems, as you can imagine, because in most cases you're running with a price auction kind of model, where basically the network and the demand basically dictates how much it will be, how costly it will be to actually run some of these systems, right? And so the ideal SaaS model would be something that captures usage as well. So basically, if, let's say, if a rollup that has been spun by a RaaS provider, if that rollup basically gets used a lot, which means that there's a lot of usage for that rollup, then the Rollup as service provider will actually charge you slightly more compared to if the Rollup was completely idle. So now this is towards the end of my talk. So let me tell you some of the things that we are thinking as a RaaS provider. I think generally speaking, the space has to see as well as space has to believe. The RaaS providers have to do something differently as well. Because so far, what we have done mostly is that we have basically taken an SDK. So we have taken, let's say, Rollup SDK like OpenStack or Amrit Kumar, and we're basically putting and hosting them on AWS. But if you go back to, if you remember my previous or my initial argument is that we should do something differently. It has to be, we should, as a RaaS provider, we should build something that is much more transparent, much more decentralized, much more permissionless. So it should not be an opaque system like the way AWS operates. But sadly, this is what we have ended up becoming, right? We have mostly ended up becoming an AWS wrapper. That's not ideal. So what's the future, and how should a better RaaS look like? So if you wanted to move towards decentralization, right? So imagine today when you, as a Rollup builder, you go to a RaaS provider and say, hey, I don't want to run any of the node infrastructure. I do not want to go into this understanding how sequences work. Can you go and manage and run my nodes, for my infrastructure? And so RaaS provider basically does that for you. And that's ideal in some cases. But what if at some point you wanted a flexibility? You say you wanted a situation where you'd say, hey, I now work very closely with Ubisoft. I would now very closely work with some other gaming companies, and I want those gaming companies to become my node operators, my sequences. Can you do that? And so this is kind of the model where I believe the RaaS provider should eventually go, where it becomes a much more open system rather than a closed and opaque system, where if where basically you're reliant on a RaaS provider to basically run everything for you, and that's not ideal because it's kind of opposite to what we have been, what's basically the opposite of the blockchain ethos in general, right? And so here's a view of things, right? But basically, RaaS would become more like a network. Instead of being a centralized party which runs your node, it will become a network where basically you as a developer, you would send a request to the Rollup and say, hey, I want to have a Rollup, and I have a certain requirements for this Rollup. So you could say, I want to have a Rollup that settles on Ethereum, that uses Celestia as the DA layer, has a certain runtime, it is optimistic in nature, it is app specific, and maybe you'd specify, for example, how many sequences you want. And you could say, hey, anyone that can come and that wants to become a sequencer has to deposit some collateral. So you could say, okay, if you are, let's say, staking ETH, and if you could stake that ETH through EigenLayer, then you're allowed to become my node operator. So it becomes a much more open system where you're not relying on one single node provider, but you're tapping into a much more decentralized network to run your infrastructure. And then this RaaS network, instead of becoming a centralized party that offers you service, now it becomes much more like a marketplace, where it basically matches people who want to have rollups and people who actually want to provide, let's say, sequencing services to that rollup. So imagine you said, oh, hey, I'm looking for 2 sequencers, and anyone that wants to operate my rollup can deposit a certain amount of collateral, and if you do so, then you can become my node operator. And this model, sequencer will come and deposit collateral, and if they deposit collateral in the network, then the RaaS network will basically select, let's say, some of the sequences randomly and then assign them to operate that rollup. So this way, RaaS moves from a RaaS operator to a much more network and protocol level setting. And so it becomes much more open, decentralized, and permissionless, and not like AWS in a closed system. The other benefit of this is that now you can tap into the network effect of all the sequences. So imagine, for example, let's say you have Block Daemon, Figment, and other very well-known validators in the market today. If they start to support your network, you can basically tap into their expertise and their network effect, their marketing ability to support your rollup. That's something that you cannot do if you're just using a RaaS provider. The ideal world will be where these RaaS providers will basically move away from being a centralized entity to a much more open system. Well, that's it for this session. Thank you very much for listening. And if you want to learn more about rollups and RaaS services, you could head over to our docs page, docs.altlayer.io. Thank you very much for this.
Thanks, Amrit, for the comprehensive presentation. I really like the comparison with the traditional software as a service model. I've done a lot of marketing in the past with different models, and it's interesting how they kind of form. And if you don't mind leaving the slides up, I'd actually like to pinpoint a couple specific things on a couple of the slides. So I'm going to ask you actually to go back towards the middle for one of the first slides where you compared zk and optimistic rollups and the costs involved for rollup as a service providers. And that one was super interesting to me because I think a lot of teams, here we go.
Was it this one?
It'll be towards the middle, actually. It was a side-by-side comparison of, there it is. So this is something that teams have to think about, right? Like, let's say we are a dApp that is looking to deploy our own app-specific rollup because we want to capture sequencer fees, or we want to be able to have more control over our environment. So when it comes to making this choice with a rollup as a service provider like Altlayer, is there a kind of framework that you guys on the BD side or that would be suggested for, okay, maybe you guys should go look to do a zk rollup? Like, is there a specific use case, application types, or team desires, customizations there versus, okay, you guys should do an optimistic rollup? Yeah, that's my first question.
Yeah, so basically, the reason why some people go for optimistic is mostly because it's easier to understand, it's easier to deal with. So people feel like, okay, you're just basically running a system where we're executing transactions. That's mostly it. But as you can imagine, zk is where Ethereum is going. Ethereum is very, very hard pushing towards zkRollups. So I think many people actually want to be future proof in some sense, right? So basically they feel like, okay, zk is the future, and therefore they want to go with zkRollups. In the end, from a let's say client perspective, we have seen that at the moment, at least, sadly, and by the way, this is going to change over the next 6 months, and by the way, this is changing almost every single day rapidly. But basically, at the moment, it can be a little bit cost heavy if you're running a zk rollup, unless the underlying, let's say, RaaS provider or underlying, let's say, Rollup SDK provider is subsidizing the cost of proving. So at the moment, many people do go to zk rollups. So if you are thinking about zk rollups, you have to make sure that either you find a RaaS provider that's going to give you, let's say, subsidized proving facility, or you can tap into the underlying SDK provider that gives you, subsidized, proving service. By the way, there are some people who do that at the moment. And so that is actually the main consideration. The second thing is to consider is basically around, let's say, VM changes. So for example, let's say at the moment, most zk rollups that are out there are EVM. There's, I think, one or two that are building WASM-based rollups as well. But if let's say if you want to have Solana VM-based rollup or move VM-based zk rollup, that's not quite out there. So in that model, you most likely will probably go with optimistic rollups. So I would say these are two main criteria. So one is, of course, the cost of proving, and the second thing is around the ability to customize, ability to pick a certain VM. That's something that's not available it's available for EVM, but not available for other runtimes.
Gotcha. And then furthermore on this slide, before we move off of it, because the rollup as a service provider, in this case Altlayer, has a network and an infrastructure set up from sequencers to explorers and provers, and there's different kind of aspects that you can just jump in and start to use compared to having to do this all on your own. Are the costs associated with whether it be zk or optimistic, are the costs of the provers in the zk sense, and are the cost of the sequencers in the optimistic sense, are those shared amongst each participant or each chain within the Altlayer ecosystem? Is there some sort of I don't want to say preferential treatment, but is there a way in which it is itemized based on block space used or gas used, or how is how is these costs that we're describing in your first point here, specifically on the zk, but broader, how are those shared amongst different chains within these Rollup-as-a-service ecosystems, and kind of how are they like prioritized?
Very good question. So this is something that it depends on certain parts of the system. So it also depends on client's preference. So there are scenarios where the client, for example, wants to have a zk rollup, but they feel like the proving cost could be quite expensive for them, and they're happy to share that with other rollup builders as well. So there are models where we actually offer a shared prover to across that basically is shared across different rollups. And there are certain scenarios where there are clients who believe like, look, I want to have my own dedicated infrastructure that does not get shared with anyone. In that case, we offer them a dedicated, system. So it depends on mostly on client's preference and how much client is willing to pay. However, when we do give people, and by the way, this is something that I think most RaaS providers do as well, where basically sometimes they give you a common playground, like a sandbox where it's shared with everyone. But this is where you get your hands dirty. This is where you get a feel of how much it might cost you eventually. And then once you graduate, once you feel like, okay, I know I get a sense of how much it's going to cost me, or then I'm going to graduate to either a shared model or a much more individualistic model where you basically pay for your services. No one is allowed to share. So we basically give people preferences, and you basically can go and pick and choose. By the way, this applies to almost every rollups. So you can actually a RaaS provider. So you can actually go and pick a RaaS provider and say, hey, can I use a sequencer that is currently sequencing someone else and also sequence my? And by the way, this is something that this is where I should also mention something like Espresso as well. So basically, Espresso is a network which offers sequencing ability. So basically, you can send your transactions to Espresso as a network, and Espresso will basically order your transactions, send them back. And they offer that in a shared model where basically a network is shared across all the rollups out there. So you don't have a dedicated sequencer for everything. But in RaaS model, you can basically choose, and you could say, hey, I want to have my dedicated sequencer, or I'm happy to have a sequencer which is basically shared across different rollups. And by the way, there are pros and cons to this model, right? One is that if you have, let's say, a sequencer that is shared across two rollups, then you can actually have, cross rollup composability, cross rollup communication quite easily. If let's say you have two different sequencers that are serving two different rollups, and then if you want to have cross rollup messaging, that becomes a slightly more complicated business. So also that is something that you should also take into account. So for example, you could say, hey, I have a rollup that is being served by a sequencer A, and I want to spin up a new rollup, and I want to make sure that this rollup actually can easily communicate with my other rollup. I want to make sure that it's actually under the same shared sequencer, so it actually gives you some benefits as well. So these are, I would say, some of the criteria that you have to consider if you want to pick a shared provider versus an individual dedicated one.
Yeah, that's where I was kind of going with that, which I appreciate you bringing that up, because I remember I did an interview in Paris with Jordy from Polygon zk EVM with regards to shared zk liquidity. And I know that they're doing different types of stacks, and zk Sync has their hyper chains, and it's quite an interesting model where we can see different zk rollups with sharing a prover, or like you say, sharing a sequencer within a Rollup-as-a-service provider, lower the cost, and then also get some of that shared liquidity and composability, which I think is something that a lot of teams are likely after if they are a DeFi app or some sort of non-siloed use case. However, in the same sense, I think that perhaps you can kind of fill us in on this, is if that a lot of the clients that you guys speak to, they're actually perhaps okay with being a bit more siloed from the rest of the ecosystem. Perhaps it's a game or something like a DYDX, like a perpetuals DEX. Is this the case? Are the rollups that are coming to Altlayer to build their own, are the dApps that are coming to Altlayer to build their own rollups app specific, mostly looking for siloed use cases, or are they looking for like more of a general purpose ecosystem, or a bit of both?
I would say mostly app specifics. There are some scenarios where they want to have a general purpose L2, But even that, when they say it's a general purpose L2, it's actually kind of a sector specific L2 that they're looking for. So basically, they want to build a DeFi rollup where they're starting. It's kind of like, I mean, maybe it's not the right name to use, but it's kind of like the Terra Luna thing, where basically you spin up a rollup where you start with a stable coin and then you add, let's say, an Aave protocol, you build a lending protocol, you build something else. So people are looking at that kind of scenarios as well, where it's not just for single application, but it's for a set of applications, I would say, that very closely can work with each other.
Yeah,
But
it.
so yeah, but in most cases it's app specific, where basically they are looking for individual block space where they can customize to suit their needs and do not have to worry about, okay, what about if I bring someone else and then they may have their own demands. So I'll give an example of, let's say, gaming, right? So there are a lot of fully on-chain games that actually want to have their own rollup simply because their contracts are actually quite heavy. But what I mean by heavy is that it's actually quite gas consuming. In some cases, you cannot even deploy them on a general purpose thing like Arbitrum Optimism today, simply because they can't, it takes, in some cases, like 10 million, 20 million gas limit directly, just one single transaction. And so they want to make sure that their block gas limit is customized to be able to accommodate that much of gas limit. And so the question is, yes, there might be some other games that might want this kind of gas limit, but maybe not all. So in most cases, I would say people are looking for app specific. In some cases, people are looking for sector specific, not necessarily general purpose.
Gotcha. Yeah, that makes total sense. If you could just go back a couple more slides. There was another one that I was quite interested in as far as the question goes. A little further. Keep going. One more, two more. I think it was like the modular one. Yeah, sorry. I think it's number 3 there. Not this one, the following one. Yeah, okay, great. Either one of these is fine. So since we're focused on the zk side of things here, with the validity proofs kind of being the important aspect, the differentiator between zk and optimism. Really, there's other factors, but that's kind of what we are seeing now. Altlayer can support, based on this graph. Is this a general rough outline of what is existence today, or does Altlayer have the capability to support a validity proof with a different VM for an app specific for a layer 2, meaning a layer 3? Is this very much a plug and play based off the current state of the modularity ecosystem that exists? And then after kind of that, is Altlayer in Rollups-as-a-service something that, as that modular ecosystem grows, that you guys can just keep kind of adapting and plug and playing?
Yeah, so let me start with this last question. Yes, the ideal scenario would be this, where basically, let's say, I don't know, tomorrow someone comes with a new VM, or tomorrow someone comes with a new kind of zk proof. By the way, just talking about validity proofs, there's not just one style, right? There are many kinds of proof systems out there in the market today, right? And so almost every single zk rollup that you see, they have their own proving mechanism. In many cases, some of them are type 1, type 2, type 3, type 4, right? And so basically, the idea is to basically make sure that we are modular enough to adapt to any new thing that comes in the market. And by the way, this is not an exhaustive thing. You could imagine, I don't sovereign rollups. I didn't include in the sovereign rollup model, right? So you could have a zk or sovereign rollup model where basically there's a peer-to-peer network which verifies the proofs. There's no single contract on chain that verifies the zk proof. But so the answer is yes. That would be the ideal model. But unfortunately, as a RaaS builder, we do not build many of the underlying SDK stuff. So for example, we do not build, let's say, Polygon. Let's say we tap into Polygon CDK, but we do not go and build Polygon CDK style systems. We sometimes do contribute to their ecosystem, do contribute to their code base. So from that perspective, from that angle, you can't build everything at the moment today. For example, you can go and build, let's say, a zk proof system that let's say, has EVM, but you can't have zk with Solana at the moment. There's some people attempting it, but there's no, for example, zk with Move VM, for example. There's nothing that exists in the market today. So our goal is not to basically go and invent all of that. Our goal is to, if someone builds, let's say, zk Move VM, Rollup, then we would support that. That's our goal. But at the moment, we like this is something that does not exist today in entirety. But this is what I would like to present. This is how the space would look like, and this is what modularity means, where you can basically take a cross product of the whole space. So you could take validity proof, and you take any runtime here, you take any purpose, and you could take any L1, L2, right, as the base chain. But yeah, not all VMs are supporting the zk model today, but you can take any zk EVM today and deploy them as an L3 or an L2 quite easily, and that's something that we obviously do today.
Yeah, that's so exciting that that as the boundaries are pushed on the innovation side, because if you remember, Polygon was working on zk EVM since like 2020, maybe early 2021, and then it was just earlier this year, late 2022, that it even kind of came out. I remember the ECC speech there, again from Jordi, actually, kind of announcing that they were open sourcing the code. So these things take time, but because you can kind of position yourself there as a I hate to say selling shovels during a gold rush, but effectively being an infra provider for people who are trying to, that allows you to have flexibility and agility. So
And by the way,
I guess
to add to this, basically, at some point of time, you may want to switch to something, right? So, for example, you could say, "Hey, I'm using Ethereum as my settlement layer or my DA layer today. Can I switch from Ethereum to Celestia, right? Or can I switch from, let's say I'm running a zk rollup today, and I'm putting, let's say, all my transaction data on Ethereum today. Can I switch from posting all transaction data on Ethereum to, let's say, putting only state delta, right?" And these are certain things that we should also be able to adapt. So we as a RaaS provider have to give flexibility to people where they could change some of these things at runtime. So while the system is running, you could basically change some of these things as well. Of course, assuming and making sure that that does not create security issues. But yeah, these are the certain things that you would be able to customize, hopefully in the future as well, with zkRollups.
Yeah, that's really, really, really cool. I know we just have a couple minutes, so I just want to ask one last question, specifically about the runtime. Are you pretty bullish on the move to different VMs for all different types of use cases and onboarding developers? Yeah.
I would say so. Look, even Ethereum, right? Ethereum and EVM is not super parallelizable, right? So someone has to go and build a parallel version of EVM, right? Solana is a good example of it. It's not EVM, but it's a parallel instance of a runtime. So I think there's room for building interesting VMs. If you look at the traditional space, there's no single language, right? There's no just C and just Java and just Go, right? There are no how many languages out there in the market today, right? And so I believe that people should get flexibility, and EVM is not the best. Yes, it's most popular, but it's not necessarily the best runtime out there, both in terms of performance, but also in terms of security, right? So I think there's a room to bring new innovation through new runtimes. And for example, WASM is a great runtime, right? Because it gives you flexibility. You can run different languages that can compile down to WASM. It runs in web browsers and things like that, which is something that you can't do with something like EVM. So I think there's room for other runtimes, including Move, Solana, and some of the others that might come in the future.
Yeah, thank you so much for coming on. It's been an absolute pleasure to sharing what you guys are building, and look forward to seeing more and more of it in the future.
My pleasure. Thank you very much for inviting me.
Cheers.